All right, so again, looking at that graph here, we have those 4 points. The axis of symmetry, that vertical line, the vertex, which is that min or that max where you change directions, and then the x-intercept or the y-intercept. Again, either x equals 0 or y equals 0. And again, it's where it crosses that axis. All right, now, moving forward here, all right, identifying features of a graph, okay? So I just walked you through that first example here, but there's a couple others in case you want to look at it, all right? So if we look at example 1, all right, that orange line.
The axis of symmetry is x equals -1.
Okay, perfect. And they would audibly talk you through it, but I will.
The x-intercepts are,
sorry, I'll turn that off for right now. Okay, these two are the x-intercepts, right? So it's at -3, 0, because I went left 3, didn't go up any. And again, 1, 0. Again, reason is that's where it crosses the x-axis. Last here, this is the y-intercept, right? Y-intercept is where it crosses the y-axis. And then that very, very bottom part, over 1, down 4, that's that vertex, right? That's where the graph changes shape. So if you know these 5 things, or potentially 4 things, right? If you count x-intercepts as just 1, if you know these 4 things, you can draw any quadratic function or any parabola. Okay, now here's just a quick difference. The only difference here is that we now are opening downwards. Okay, so our vertex is still going to be that max point. Okay, it's at 1, 3. This is our axis of symmetry, so the left side is equal to the right side. We cross the y-axis here, and then we have 2 x-intercepts. All right, and something I'll point out is, yes, it's not always a whole number where we cross the y or the x-intercept. So if you ever calculated this and it told you 2.6, I am totally comfortable with somewhere between 2 and 3. Okay, as long as it looks like it's a relatively close to the number, you're going to be correct. Okay. All right, and again, says the axis of symmetry passes through the vertex, and that's not a coincidence, right? The vertex is the point where it stops going in one direction and reflects over. So your vertex will be that one point, and your axis of symmetry will just be the x value for that. So if you look here, the vertex is 1, 3. Our axis of symmetry is x equals 1. So this entire vertical line along x equals 1. All right. So then moving forward here, okay, you can try this on your own, or we can try this together here. We'll just go through one and you can do the other one by yourself. I want to do this one since we've already done a lot of upward facing guys. All right, but the x-intercepts, okay, so the x-intercept, that's where it crosses the x-axis here. So it's -2, 0, right? That's the first one, is -2, 0, right? So we write x first, then y. For this other one here, it's over 4 and up 0. So I've got -2, 0, and 4, 0. Okay, perfect, right? For the y-intercept, it's where it crosses the y-axis. So x is equal to 0, and I go up 8, so that should be 0, 8. All right, vertex, that's that max point there where it's going to inflect over. So again, using my best judgment here, okay, it looks like it's up 9. And if I carry that down, it looks like it's over 1, up 9. So it should be 1, 9. Perfect. All right. And then the axis of symmetry is that line, that vertical line where if I fold it in half, it looks like a mirror image. So that's going to be at x is equal to 1. All right. Or the x coordinate for our vertex. All right. Okay, so there are 3 forms of this equation, right? Just like we had for our linear equation. There are 3 forms. There's standard, there's vertex, and there's intercept. There's standard, there's vertex, and there's intercept. All right? Now, the standard form, okay, in linear is y equals mx plus b, or y equals ax plus b. All right? Only difference here is now we have that ax squared term. So our standard or general form is y equals ax squared plus bx plus c, where again, a is a real number, so is b, and so is c, and a cannot be 0. okay? If a is 0, it's a linear function. It's just bx plus c or ax plus b, right? Doesn't really matter. Okay, so as long as a is not 0, this is our standard form for a quadratic function, okay? Our vertex form, okay, our vertex form, the reason we call it the vertex form is because it takes into account our vertex point, right? That max or that min point. So our vertex point, we call it at HK. We call it at HK. All right, H is just a variable for our X coordinate and K is a variable for our Y coordinate, right? So the vertex form of our quadratic function is Y minus K. So Y minus the Y variable of our vertex point equals A parentheses X minus our X coordinate for our vertex point squared. All right, again, A, H, and K have to be real numbers. A, H, and K have to be real numbers, and A cannot be 0. Okay, now, important to point out, K and H could be 0. Okay, so K and H could be 0. Our vertex point could be at 0, 5 or 5, 0, right? So K and H can be a 0. Only thing is that A cannot be a 0. Okay? That is our vertex form. All right, and then finally here is the intercept form. Okay, so this one looks familiar. Okay, except this is where we have y equals a times by x minus r1 times by x minus r2. Okay, and what those r1 and r2 stand for are the x-intercepts on the graph, right? So it would be located at R1, 0 or R2, 0. Okay, and if this is confusing, we will work through a couple problems together, all right? And I'll share with you, again, I take notes while I'm going through this, so I'll share with you what my notes look like for that slide, okay? So again, we have 3 forms of the quadratic function. First is our standard form, right? Ax squared plus bx plus c. Again, the only thing is a, b, and c have to equal real numbers, and a cannot equal 0. All right, and this is what we've been dealing a lot with. Okay, number 2 is our vertex form. So it looks like y minus k equals ax minus h squared, right? Where the vertex point is hx, right? Again, h is the x coordinate of our vertex, and k is our y coordinate. And again, if our graph looks like this would be our vertex point, right? And it is at some coordinate hk. All right. And then finally here again, our intercept form. That is our factored form, right? That looks like our factored form of our quadratic, right? We have y equals a times by x minus r1 and x minus r2. If I change this slightly, it looks like our factored form. Okay, so it looks like our factored form here, right? So it's very, very similar. But the only difference here is now we're saying that these values, R1 and R2, stand for our x-intercepts. They stand for our x-intercepts, right? So again, if this is my graph here, this is x-intercept 1 and x-intercept 2. So this is at some coordinate R1, 0. This is at some coordinate R2, 0. Okay? So again, we can go through this now knowing this, and we can work through problems relatively, again, I'm going to say relatively. We can work through problems relatively quickly if you know how to dissect, right, what the forms are telling you, right? And we'll work through some problems here. And then finally here again, most common forms, we've got linear versus quadratic. Okay, so linear versus quadratic, right? Again, linear is that ax plus b, and quadratic is ax squared plus bx plus c. Okay, so moving right along here. Okay, what kind of function? All right, what kind of function? So remember, linear is that y equals ax plus b. So something like this, y equals some number, x plus some number. Y equals x plus some number, right? Even this one, I know it's a little bit confusing because it's in a different order, but look, it's got x to the first power and it's got a number, right? Now, something like x to the third, right? We talked about that. X to the third is not a quadratic. We can't pull that x out, so it's not a quadratic. But we know that that looks like our factored form of a quadratic. This is a new one we just learned. That's our standard form. And then this 1 over x is nothing, right? So in linear, you can see linear in pretty much one form. Just depends on what values you have in front, okay? With quadratic, you have, like I said, we have those three forms that we're going to get more familiar with. We have our standard form, we have our intercept form, and we have our vertex form. All right, and we'll get more familiar with both of those. So this one here, that's our vertex form, and this one is our intercept form, and then the last one there is the one that you're more familiar with, okay? But let me remind you here, this caret 2 means raise that to the second power, okay? So this is what it looks like on your calculator. If you were to plug in 3x squared, you'd have to plug in 3x caret 2. Okay, you have that little caret button. It's the button that's right underneath your clear symbol on your calculator. Far right, it's the symbol that's underneath your clear symbol. Okay. Moving forward here, okay, moving forward here. It's asking us to figure out if it's standard, vertex, or intercept, okay? So if we start with the easy one, in my opinion, our standard form, that's our ax plus bx plus c. So standard, okay? Our ax plus bx plus c. Okay, now this one, trying to trick you here, okay? They just rearranged it differently. They put the c value first, but that is still standard form, okay? And then that one is still standard form, okay? It's got the x squared, okay? The difference is that maybe the middle value, instead of having 2x, it canceled out and we had 0x. So those are our standard forms, all right? And the easy way that I can tell the difference between a vertex and an intercept form is our intercept form looks like it's factored. So that one would be our intercept form, okay? This one would be our intercept form, okay? And the vertex form is the one that has y minus something, okay? So y minus something, y minus something, x minus something. That would be our vertex form, okay? Again, you should be able to do this one. It's just a click. It's not a click and drag, but I wanted to walk through it in case you couldn't do that one. All right. Now, this is actually a really, really good video, so we're just going to watch it together, and I'll talk you through it. But this is talking about converting from vertex form to different forms, okay? So to change an equation from vertex form into standard form, you simply multiply everything out and combine like terms, all right? So example, if we convert the following function to standard form here, y equals negative x plus 2 squared minus 7. All right, so we're going to multiply this out. So first thing we're going to do is we're going to square this term, right? So we take this and we go x plus 2 times by x plus 2, right? So you would square that term out. And when you do that and you combine your like terms, you end up with this value here. All right. Then we're going to distribute the negative sign. Okay, so we bring that negative sign to all of the values. We, again, combine like terms, and we're left with our resulting standard form. Okay, so again, the thing I want to point out, maybe this step was a little bit confusing here. So if I were to type this one out, again, what we did was we said negative x plus 2 multiplied by x plus 2 minus 7, right? So that would be the form that's there. And then we we FOIL out the x plus 2 terms, okay? So we FOILed them out, all right? So again, when it says square the x plus 2 term, that's what it means. You took the x plus 2, you wrote another x plus 2, you FOILed it out, and then we combined like terms. And that's how we got to this equation here, okay? Moving forward here. All right, whenever you're converting from one form to another, it is usually best to go to the standard form, okay? It's kind of the easiest. It's like our go-between, all right? So if we're gonna change from the vertex form to the intercept form, we're gonna first go to the standard form and then we're gonna factor, right? Because I told you the intercept form is basically the factored form of our quadratic. So if we have our original function here, okay, we're going to try to get to our standard form first. So we're going to multiply everything out. So square the term. Again, you're going to have x plus 1 multiplied by x plus 1. You FOIL that out, and you end up getting the following right equation. Okay, you're going to bring that 4 to the other side, right? You're going to bring that 4 to the other side. And if we pause for a second, that is our standard form. That is our standard form right there, okay? ax squared plus bx plus c. Then what we do is we just factor the quadratic expression, okay? So the thing that we've been doing this whole time, right? And we got to learn, or we got to know if we've got to use the complex version, if we've got to factor things, right? And that's what we're learning with Algebra 2 here. But for most of these examples, they're going to be pretty simple ones where there's not an a value in front. There's not like a 4 that we have to take out, okay? But once you get to the standard form here, you're just going to factor the expression like we know how to do. All right. So again, that's our final answer, going from vertex to intercept form, okay? All right. So here it has practice, right? And this is a video that you can watch on your own and it'll walk you through, but I actually wanted to calculate these ones out with you so that you had that practice. Okay, so again, we are looking at factoring from the vertex form to either the standard form or the intercept form. Okay, or the standard form or the intercept form. So for this first equation here, it's asking for us to put this in the standard form. Okay, so it's asking us to go from vertex to standard form. All right, so we're going to follow this first procedure, which is multiply everything out and combine like terms. So what this looks like, we have y minus 3 equals negative 2x. And then when we square this term, right, again, it's x minus 1, right? We FOIL out. I still have the negative 2 on the outside, but now I have x squared minus 1x plus 1 is equal to y minus 3. All right, so now I'm going to combine like terms. Okay, I've got x squared minus 2x plus 1. All right, and I wish we were done, but we still have to FOIL again. Or sorry, not FOIL, we have to distribute. We distribute that negative 2. So now I have negative 2x squared plus 4x minus 2. It's still equal to y minus 3. All right. Then the final step here is I have to add 3 to both sides. So my final equation is y equals negative 2x squared plus 4x plus 1. Right? And to check to make sure that I'm correct, if I'm in the standard form, I should have ax squared plus bx plus c. I've got an x squared term with a value, so that's my ax squared plus bx plus c. All right, so I am in standard form. All right, and when you walk through the when you walk through the video, it will not give you the full steps. It'll just have the answer for you. So again, if you want to go back there, you can check that. All right. Moving forward here, okay, the next one is y plus, let's make this one a little bit more difficult here. Oh, nope, it still says convert to standard form. Okay, so we're still gonna take this one and go to our standard form here. All right, so we have y plus 1 on the left-hand side, we don't touch yet. We still have that 1/2 value out in front. Okay, but we've got to get that square. So we've got x plus 4, x plus 4. All right. We keep all the other values. Again, we FOIL this guy out. And it ends up with x squared plus 8x plus 16. Okay, now I distribute my 1/2. All right, I distribute my 1/2. So I have 1/2 x, and I don't know why I kept the parentheses. I've got 1/2 x squared plus multiplying by 1/2 is like dividing by 2. So I've got 4x, and half of 16 is 8. All right. Now the final step is to subtract 1 from both sides, so I get y by itself. So I have y equals 1/2 x squared plus 4x plus 7. And again, if I want to check, I'm in my ax squared plus bx plus c form. I am in my standard form. Okay, so from there, if we wanted to go even further, okay, we would, if you wanted to get to the intercept form, we would just have to factor. All right, but you guys are getting enough practice in that right now in Algebra 2, so we're gonna skip that for right now. Okay, so you guys are doing all of that in Algebra 2. So again, you should know how to factor that stuff. All right, and again, there's a couple more problems here if you want extra practice, and you can check, they give you the answers. And we went through 2 of them. All right, now, if we go from the intercept form, right? So we just worked with going from the vertex form to the intercept form and the standard form. But now we're gonna go from the intercept form to either the standard form or the vertex form. All right, so the video again, to change from the intercept to the standard form, all we do is we simply multiply the terms together, we combine like terms, and we simplify. So a good example of this, right? We take our original function, we use the FOIL method, right? We multiply the 2 binomial terms, we FOIL, right? We combine like terms. Then we're gonna distribute that -4 out, and we are in our standard form. Okay, we are in our standard form. Okay, perfect. But now if we're going to go from the intercept form to the vertex form, here's where it gets a little bit more difficult. Okay, we're still gonna go to the standard form. Okay, so we're still gonna go to the standard form, right? So our original function, we still FOIL that out. We still combine like terms. We still carry the -4. But this is where it gets a little bit different. Okay, our vertex form has to pass through our vertex, obviously, right? It deals with our vertex. So this is gonna work with completing the square, okay? And this is where it's gonna be a little bit new to you guys because we just learned about completing the square today, or you will learn about it a little bit later, okay? But majority of you have already done the work for this. So again, completing the square is making it so that it can be one of those really nice squared functions for us, okay? So to complete the square for 60, right? We just move the 60 out, okay? We move the 60 out, and then we can pull out a 4 from this quantity, right? So we have x squared and 2x. Okay, and again, we'll talk more about this, and I can help you through it if you're stuck, but you should have already learned about completing the squares when you were doing the algebra 2 stuff, okay? But in order to complete the square, you add a term here, okay? So you add a term. Let me write that out. So you add a term, or a constant, I guess I'll say constant, right? You add a constant that is b divided by 2a squared. B divided by 2a squared. So if we look at this example, b is 2. So 2 divided by, our a value is 1. So 2 divided by 2 is 1. And 1 squared gives us 1. So we add a 1 to both sides. Okay, we add a 1 to both sides. All right, and we'll walk through another example, actually walking through it to help you guys. All right, but we complete the square so that we can factor this out and make it easier. All right, because once we do that, we have x minus 1 squared, and then we can bring the 64 to the other side. So this is the only one that I think personally might be a little bit difficult for you all, is going from the intercept form to the vertex form, okay, or going from standard form to vertex form. That's the only one that I think is more difficult. Okay. Don't know why it was doing that. Okay. So for this one here, okay, you've got converting to standard form, okay? So, ooh. Apologies. All right, so you have negative 1/2 x plus 2 and x minus 5, all right? So when you check your answer there, you should be able to look and see, but all we did here was to convert to the standard form was we FOILed out and then we distributed the negative 1/2, okay? And we're gonna move forward again with problems that are a little bit, in my opinion, a little bit more difficult here for you, all right? So this one here, we've got 3, let me share my screen with you guys. 3 times x minus 8, right? And again, if we're getting this in our standard form, we're going to FOIL. So I've got 3x squared minus 6x minus 16, okay? And then I distribute my 3. So I've got 3x squared minus 18x minus 48. Okay, minus 48. Same thing with this one. If we were to do this guy, you would just FOIL out. All right, x squared minus 2x minus 15. And then distribute the negative 4. So negative 4x squared plus 8x plus 60. Okay, and that would get me to my standard form here. All right, same thing with the 1/2, okay? I just know that 1/2 is kind of confusing. Remember, you just divide everything by 2. So if I FOIL this first one out, x squared minus 14x plus 45. All right, when I distribute the half, I end up with 1/2 x squared minus 7x and then plus 45 over 2, which you can shorten if you want to 22.5, but I just leave it as 45 over 2. Okay. All right. Now moving forward here. Okay. This is a very, very quick unit here because it's all about drawing graphs and being able to figure out how to work these things through. Okay. So for your study guide here, okay, for your study guide, same thing. I'll post the answers for it, but let's walk through it quickly. Okay, for your study guide. All right, graph of functions called parabola. Okay, you should be able to identify real quickly these different points on the graph. Okay, axis of symmetry of the graph always is a linear equation, right? X equals whatever. Okay. You should be able to point out different points on the graph, right? Reading the line. So for this example, each tick mark is 1, right? So for example, this x-intercept is at 1, 0, right? So x-intercept is at 1, 0, right? You should be able to figure out the rest of these. And again, give this a good try. And if you can do this, then you're rocking and rolling here. All right. This is going to be insanely helpful for you. So please make sure you write this down. You use this on your tests, okay? Because it's going to ask you a lot of things about standard form, vertex form, intercept form, all right? And if you can do that, it's going to be easier for you, okay? Being able to distinguish between linear, quadratic, and neither, right? Basically, a linear function is going to have only an x value, right? It's x to the first. A quadratic, if you multiplied everything out, is going to result in an x squared. And then if it is 1 over something, that's not an x squared, that's not an x, that's 1 over x, right? So that doesn't count as either. And then if you have an x cubed, right, that is not a quadratic either, okay? Same thing, identifying the forms. If you have that little cheat sheet next to you, this is really simple, okay? And then converting to standard form. Okay, that's going to be the most important. So going from vertex form to standard form, or going from intercept form to standard form, okay? The one that's going to be difficult here is this converting to vertex form, okay? And we can walk through one of these problems together, all right? But this has to deal with the, sorry, I'm trying to find it for you. Okay, this has to deal with completing the squares, all right? And so I'm going to post a video later on today in Algebra 2 about completing the squares. But a lot of you, like I said, a lot of you have already done the work for that. So I feel comfortable moving on past this. But if you haven't done the work in Algebra 2, please, by all means, go do that so that you aren't confused. Okay, but vertex form, if we have to convert to vertex form, this has a lot to do with, like I said, completing the squares. Okay, and if we take a minute right here to talk about this, okay, what that means is we still go to standard form. So step 1 is still going to be standard form. Okay, standard form. So for example here, we're going to first FOIL out, and I'll zoom in. We're going to FOIL out, okay? So I've got x squared plus 8x minus 9, all right? Then I distribute negative 2x squared minus 16x plus 18, okay? And what I can do now is, like we said, what we can do now is we move over a space, right? So a space, and we keep our plus 18, because this is where we're going to complete the square. Okay, we're going to complete the square there. And so what that looks like is, first, we want to make sure we can get rid of that a term. So we pull negative 2 out, and we have x squared minus or sorry, plus 8x. Okay? Plus something. And 18's on the outside. All right, 18's on the outside. So then what we look at is, all right, what is going to complete this square? And this value here, this value, as you're going to learn or should have already learned in Algebra 2, is b divided by 2a squared. B divided by 2a squared. So if we look at this, this turns into 8 divided by 2 times 1 squared, or 4 squared, which is 16. So we write our 16 there. We write our 16 there. Okay? But here's the problem. Here's the problem. We can't just add numbers and not consider where they're going or what they're doing. So effectively, if you look at this, if it looks like on this whole side, we just subtracted 2 times by 16, which is 32. We just subtracted 32 from this side. So to account for this, we have to subtract 32 from the other side. You have to subtract 32 from the other side, right? We have to be even. We can't just add things and not consider them. All right? We're almost done, I promise, with this one, okay? So we had to add something to the other side, okay? We can now take away this 18 from the other side as well. Okay, so I'm left with y minus 32, oh, sorry, not 32, y minus 50 equals negative 2 times by x squared plus 8x plus 16. All right, we're almost there, I promise, we're almost there. Now remember, vertex form looks like y minus k equals a x minus h squared, okay? So the only way we can do this is if we factor this guy. And our factor needs to end up being 2 of the same thing so we can square it, right? So what that looks like here, if I keep moving with this problem, okay, equals negative 2, all right? X is a perfect square, or x squared is a perfect square, and so is 16, right? That's 4. And since this is positive and this is positive, I know it's going to be plus 4. So the way that I could write this is x plus 4 and x plus 4, right? If I FOIL it out, I get my original. But it's not vertex form, right? Vertex form has to be something squared. So I can combine these two. Y minus 50 equals negative 2 times by x plus 4 squared. And I am now in my vertex form. I am now in my vertex form. So this is my final equation. All right, and again, personally, I think this is the most difficult. This is the most difficult form for me. All right. I'm going to stop sharing for a second. I want to look at you all. You can either give me a reaction or you can give me a physical thumb up. Do you guys, if you want, we can go through one more problem of going to vertex form, or we can keep moving forward. Okay, if you want to go through one more problem of vertex form, give me a thumbs up. I see no thumbs. Okay. So then I'm going to take that as you all know how to complete the squares and you feel confident doing this moving forward. Okay, awesome. So then again, if you need it, here's the other problem we were going to work through. All right, it walks you through what you should get and how you should get there. Okay, so please, if you get stuck on vertex form, go back to the notes and also go back to here. All right, so that's the study sheet for this guy. All right. Yes, totally. All right, for the checkup here. For the checkup, like I said, I'll still post the answers for this one. All right, but if I can quickly move through this here. All right, identify the following. Okay, you should know how to do that now. All right, be able to tell me which form is which, right? So looking at standard form, and this is the one that would take you a long time to do, which is why, again, the concept checks aren't, or the checkups aren't mandatory. Okay, converting between them, but knowing that there are similarities, okay, knowing that there are similarities. All right, for questions 16 through 17, list the following. Okay, so if you take nothing else from these concept checks, take the tips. Take the tips. Okay, so one way to figure it out is to figure out in the vertex form. Look at this, right? You can find X, you can find Y, you can find H and K. All right. So again, looking through it, identifying points. All right. Looking through identifying points. All right. And then, okay, there's only one quiz, so that should be a really good relief. There's a ton of quizzes in Algebra 2, but there's only one quiz in pre-calc. All right. Moving forward here with pre-calc here. Okay, so overview. I'm going to try to go through this quickly so I don't hold you late here. Okay, graphing the quadratic functions. All right, now that you understand the different points, you understand the different equations. Now all you have to do is put them together, right? And that's why it's literally called putting the pieces together, right? Put the pieces together, plot it on a graph, and connect the points. So if A is greater than, if A is less than 0, it's going to open downwards. If it's greater than 0, it's going to open upwards. All right. Going from standard to vertex, right? In the previous lesson, you learned the technique of completing the squares, okay? Also, if you have standard form, here's kind of a hint, hint, nudge, nudge, potentially a shortcut here, all right? The x coordinate of the vertex point can also be determined as negative b over 2a, negative b over 2a. So what does that actually mean? Let me show you. All right. Okay, so standard form is this y equals ax squared plus bx plus c, right? And again, if a, this first value, is greater than 0, it opens upwards. If it's less than, it opens downwards, all right? The y-intercept is where x equals 0. So basically, if I plugged in 0 for this one, that term would cancel and that term would cancel, okay? So our y-intercept is at the location 0c. 0c, right? So 0c. If we're looking at going from standard to vertex form, right? Going from standard to vertex form, we looked at completing the squares, but also, okay, also, we know that the vertex is at point hk, and we know that the vertex form is y minus k equals ax minus h squared. Okay, so if we just knew what k and x were, this would get a little bit easier. So we can determine h through the equation h equals negative b over 2a from our original ax squared plus bx plus c. Okay, we can figure out our x coordinate. Again, h is the x coordinate of our vertex. Okay, so we could figure out our x coordinate, and that's also the axis of symmetry. And if we wanted to figure out our y coordinate, all you got to do is plug x into your equation. Right? So for example, if you found out through this equation that h, or I guess I should change that first off, you plug h into your equation. Okay? You plug h into your equation. You can then solve for your y coordinate. Okay? All right, we can plug h in and solve for our y coordinate. All right. Now, moving forward here with apex, okay, that's what it's showing you. It's saying the x-coordinate for the vertex point is equal to this. With this much information, right, knowing where the x-intercept is, knowing where the y-intercept is, knowing where the vertex is, knowing where the axis of symmetry is, if it opens up or down, okay, you can draw a pretty accurate graph, right? So knowing just a couple points here, you can be able to figure it out.
Given in standard form. First, note that the graph will open upward since a is greater than 0. Next, find the y-intercept. To do this, first set x equal to 0. The function then indicates that when x is 0, y is 7. So the y-intercept for the function is 7. Now you can turn your attention to locating the vertex of the parabola and determining the axis of the symmetry. Previously, you saw that the axis of symmetry is found by making x equal to negative b over 2a. If you substitute in the b and a values from the function, you can find that the axis of symmetry must be at x equals 2. Since the vertex is located on the axis of symmetry, you can find the y-coordinate of the vertex by evaluating the function at x equals 2. Doing this shows you that the vertex of the parabola will be located at the x equals 2, y equals 3. You now know the axis of symmetry, the vertex, and the y-intercept for the function, and you also know it opens upward. You might be able to make a rough sketch of the rest of the function with this information, but it would be helpful to find a few more points to make the graph more accurate. You know the function must be symmetric around x equals 2. So you can reflect the points for the y-intercept across the axis of symmetry to get another point at x equals 4.
Okay, so what he means by that is we know that this is our axis of symmetry. We know that this is our y-intercept. Those are things that we absolutely know. And you can reflect is what he's talking about. But what he really, like, how you can figure out this reflection and make sure that you are accurate is, look, you go over 2, right? Because it went 1, 2. So to get to this point here, you had to go over 2 and up 1, 2, 3, 4. Okay. So now what you do is you want to reflect that across the line. So we're still going to go over 2 and we go up 1, 2, 3, 4. Right. So that gives us another point because we are reflecting across this axis of symmetry. Okay. Because it's got to look the same on both sides of the line.
Y equals 7. You can find more points by plugging in other values of x into the function. When x equals 1, you can calculate that y must equal 4, and when x equals 3, you can calculate y equals 4. Finally, there are enough points on the graph so you have a very good idea of what the graph should look like. You can now connect the dots using a smooth parabolic curve to represent the function.
Okay. So my general rule of thumb is having 4 or more points, okay? 4 or more points. Because with 3, you could have drawn this a little bit deeper. You might draw it a little bit wider, right? Usually 4 or more points is what my recommendation is when you're drawing these graphs, okay? And again, to find those last 2, he just picked some random value for x. You could have picked x equals -1 if you wanted, or x equals 6. Right? But he kept it something simple that he could do the math very quickly. And all he did is he plugged it back into this equation so that he could get a value for y. All right. Another exercise here, 2 minutes.
Now practice graphing another function written in standard form. First, you can see that the graph will open downward since a is less than 0. Next, find the y-intercept. To do this, first set x equal to 0. The function then indicates that when x is 0, y is -2. So the y-intercept for the function is -2. Now you can turn your attention to locating the vertex of the parabola and determining the axis of symmetry. Previously, you saw that the axis of symmetry is found by making x equal to -b over 2a. If you substitute in the b and a values from the function, you can find the axis of symmetry must be at x equals 2. Since the vertex is located on the axis of symmetry, you can find the y-coordinate of the vertex by evaluating the function at x equals 2. Doing this shows you that the vertex of the parabola will be located at x equals 2, y equals 2. You now know the axis of symmetry, the vertex, and the y-intercept for the function.
Right? So now again, you know you had to go up 1, 2, 3, 4, and over 2. So you can still go up, over 2 and down 4, and you have another
And you also
point.
know it opens downward. You might be able to make a rough sketch of the rest of the function with this information, but it would be helpful to find a few more points to make the graph more accurate. You know the function must be symmetric, around x equals 2, so you can reflect the points from the y-intercept across the axis of symmetry to get another point at x equals 4, y equals -2. You can find more points by plugging in other values of x into the function. When x equals 1, you can calculate that y must equal 1. And when x equals 3, you can calculate that y equals 1.
Okay? And this is if it's in standard form, right? Again, you could also try to solve this and factor it, and that's what we're going to work on next. Is if it's in intercept form, we know immediately what the x-intercepts are, okay? But
You now connect the dots using a smooth parabolic curve.
there you go, right? You connect the dots. It has to look smooth. It makes a U shape. It doesn't look like a V, right? It's got to be clearly curved there, okay? Now, if we have the vertex form of the equation here, okay, if we have the vertex form of the equation, same thing. A is greater than 0, it's going to open down. If A is less than 0, it's going to open down. If A is greater than 0, it's going to open up. All right. And then the helpful hint for this guy is that the vertex of the parabola, we already know, is at the coordinate HK, right? We know it's at HK. So that immediately, if we're in this form, that immediately gives you the point. It gives you the vertex, right? And if we know that the vertex is at HK, we know the axis of symmetry is at that vertical line at x equals h, okay? And then we just need a couple more points and we can solve our graph here.
Practice sketching the graph of a function given in vertex form. First, note that the graph will open downward since a equals -1, which is less than 0. Next, you can find the vertex of the parabola with h and k. H gives the x-coordinate of the vertex, and k gives the y-coordinate. So the vertex is located at x equals -2, y equals -7. This also gives you the axis of symmetry, which is just the line passing through the x-coordinate, x equals -2. Now that you have the vertex and the axis of symmetry, you just need a few more points to be able to draw an accurate graph. To find more points on the parabola, you can create ordered pairs by plugging in numbers for x and solving for corresponding y values.
Again, he just picked random values for x.
When x is -1 in the function, you find that y equals -8. When x is 0, y equals -11. First, you found the vertex at x equals -2. You can find more points for the graph.
Okay, so then once you've got 3 points, right? Or 2 points on one side of the vertex, all you have to do now is remember, we reflect across this line here. So it looks like we went over 1 to get from our, we went over 1 and down 1 to get to this point here. So we go over 1, down 1. Here's another point, okay? To go from either the original point or this new point to get to this guy here, we had to go over 1, down 3. 1, 2, 3. So again, we go over 1 more, down 1, 2, 3. Okay, so now when we get to the end here, your vertex, okay, your vertex is that top point, and then we reflected all of those points along the other ends, and we should be able to.
Function looks like.
It's very
you can
close. Very close. Okay, so my points were relatively close. Okay, again, not expecting the greatest artistes in the world, because I definitely am not. All right, and so when you have that there, though, you've got your shape. You can connect them using that smooth curved line. All right, same thing here. I'll let you watch this one on your own. But again, you find the vertex. Okay, you now have your axis of symmetry. You pick a couple values for x, and you can solve for y. And then you reflect them across the line and connect using
Practice.
Just that smooth curved line. All right. Now, intercept form. All right, this is the last one we're going to talk about here, and I know I'm running out of time, so I'm going quickly. All right, intercept form. This is where you have y equals a, x minus r1, x minus r2. Okay, and what that looks like is, again, you've got, again, parabola opening up or down depending on what a value is. And the x-intercepts of the graph are found at r1, 0 and r2, 0. Right? Because remember, when we solve for the x's, we made this one equal to 0 or this one equal to 0. And if we did that, we can solve for our x-intercepts. So immediately, if we look at this form, we know our parabola is going to open up or down. We know where our two x-intercepts are going to be. And then here's a new one here. We know, or we can calculate what our vertex is going to be, because it's the average between the two x-intercepts. It's the average between the two x-intercepts. So you add r1 plus r2 and you divide by 2, right? And that gives us our x-intercept for the vertex, right? So last video here, and then we're going to be done.
Practice sketching the graph of a function given in vertex form. First, notice that the graph will open upward since a, the coefficient in front of the equation,
He meant intercept form.
is 1, which is greater than 0. Next, find the x-intercepts. When either of the expressions in parentheses equals 0, it indicates an x-intercept. For the left expression to be 0, x must be negative 1. For the right expression to be 0, x must be negative 2. This gives you 2 x-intercept points. Because of the symmetry of the quadratic functions, you see that the x-coordinate of the vertex must be located halfway between these two intercept points. So the x-coordinate of the vertex must be negative 3/2. When you use this value of x in the equation, you find the corresponding y-coordinate for the vertex, which is negative 1/4. Now that you know the location of the 2 points and the vertex, you just need a couple more points to be able to draw an accurate.
Okay, right, and we know the rest of this. Okay, so once we found the x-intercepts, you pick an x value, you pick a y, or pick a y value. Again, I always pick an x value. You plug in, you solve for y, right? And then you can reflect that across the axis of symmetry line here. Okay, and final thoughts here, our study guide. All right, so the study guide for this one, again, super helpful. Have these with you when you take your quizzes. All right. Again, either the function is going to open up or down depending on what a is. You can figure out the y-intercepts of the graph and the axis of symmetry based on the information you have straight up from the equation. Same thing here. Okay. This one's asking you then with a standard form. Okay. Looking at it and tell me if it opens up or down. What's the y-intercept going to be? What's the axis of symmetry? What's the vertex? Okay. And then doing the exact same thing, you should be able to pull out all of that information. And personally, what I do is I would write it over here, pull out all that information, and then plot it on your graph. Okay, and your graph's going to look something relatively like this. Okay, then you repeat that process for our vertex form. Okay, you repeat that process for our vertex form. All right, and then finally, you repeat it for our intercept form. Okay. Again, I really think that if you can do this and you have this next to you when you take your quiz, you should ace it. You should ace your quiz. Okay. And then last thing here, your checkup. Okay, it is much of the same of your study guide. Okay, it is much of the same of the study guide. Okay, label the vertex and axis of symmetry. Okay, so you're gonna label. You're gonna graph the functions based on this, right? And you're gonna label the vertex and axis of symmetry. But the difference between this and the study guide is the study guide asks you for all of those individual parts before it tells you to graph. So if you get to a question that looks like this, still go through and ask those same questions that your study guide did, right? Is it gonna open up or down? What are my x-intercepts? What are my y-intercepts, right? And it's all dependent on what form your quadratic is in before you even touch anything, right? So this one's in our standard form. So you would go back here and you're gonna answer these questions, okay? It opens this way. The y-intercept is this, the axis of symmetry is this, and the vertex is this. And I know that because I'm looking at my quadratic function in standard form, okay? But this one is in obviously vertex form. So you would go back to your study sheet, okay? And you would follow this process here, okay? Is it gonna open up or down? What's my coordinate of my vertex? What's my axis of symmetry, right? Those are the questions that you ask, okay? And then again, finally here, you're gonna do the same thing for the last one, all right? You're gonna match the graphs, okay? So this one here, I hope it isn't super difficult, okay? But you're basically doing the reverse. So you're pointing out a couple things, all right? So example, you're gonna point out, well, the graph is gonna open upwards or downwards. This is my vertex. This is where my axis of symmetry should be. So you should just be able to match them up relatively based on the information that you know, okay? Relatively based on the information that you know. All right. Apologies that again, I ran over late, so I'm super sorry. I just want to hit a couple final highlights with you guys. All right, a couple final highlights with everybody. All right, so clearly we didn't get as far in either class as I wanted us to. All right. But that just means that we have a little bit extra work to do. And again, I apologize. I'm going to try to make those videos this weekend really short and to the point. But I really want to make sure that we are learning all this information so that we can be successful when we move forward here. I don't want to really cut anything out if we can avoid it. All right. But my hope and goal for you is that you can get through all of Unit 3 for Algebra 2 and all of Unit 2 for Pre-Calc, okay? And again, a lot of you have already finished a lot of this, so please feel free to keep going with that, all right? And final reminders here, I will post videos for everything that we haven't gotten a chance to talk about here. So technically, even if you did this, I'm still gonna make a video. So we got all the way to 3.3. So I'm gonna make a video for 3.4, 3.5, all the way to 3.10. So I will make quick little videos that walk you through problems, that walk you through Apex for all of these, okay? And I'll post that on Classroom. Same thing, I will make a video for 2.3, 2.4, and 2.5, okay? I will make those videos, but if you don't need them, if you don't need those videos, you do not have to watch them, okay? But you definitely have to get all of the stuff on Apex finished. All right, pay attention to what's extra credit if you want extra credit or if you don't want to do the extra work. And then come Monday, we will review all of this so that you can crush both of those tests. All right, apologies. Does anyone have any final thoughts, questions, anything, need anything from me? Awesome. Okay, well then look out for those videos. I'll dump a lot of stuff on Google Classroom and I will see you guys on Monday then. Goodbye.